Okay, sorry about that. We're back here. For question 25, it's not very clear what they're asking, right? I had to go actually check what the answer was to see what they're asking, because use differential to estimate the maximum error. Maximum error in what, people? Um, and since we've got a circular disk, I would assume it would be either the circumference or the area. It could be either one. And from the answers, what I can ascertain is that they want to know what's the maximum error in calculating the area. Okay, so we're told it's got a radius of 24 centimeter, but because of the error, it could be 24.2 or it could be 23.8, right? Because it's kind of this is a plus or minus. The way we use differentials, though, to do this is we take our formula for what we're trying to maximize or minimize. In this case, maximize well, not that we're trying to maximize our error, but we're trying to see what it could be. Error is equal to pi r squared, right? So that's what we're going to use. Using differentials, we'll take the derivative of both sides, and what we see is that what we're given is that the information is that the radius is supposed to be 24. However, there is an error in measurement. DDR could be plus or minus zero point 0.2. So that's our change, right? So we use implicit derivatives here. Take the derivative. Derivative of area will be derivative of area with respect to r. Take the derivative of r. That's going to be 2r. Pi is a constant, so it just sticks there. And then we get the differential of r is d dr. Okay, what is ddr? Well, that's 0.2. What is r? It's 24. And that will give us what the sort of the plus or minus would be in the area. So with the plus or minus 0.2, how much error could we have in the calculation of the area? That's going to be 2 times 24 pi times zero point 0.2. Multiply that all together, and what we get is 9.6 pi. To get the relative error, so this is the A part. So maximum. What's the relative error? Well, then relative error is a percentage. So we would take this maximal error and divide by what we think we're getting, which is pi r squared. So we're going to take, so for the B part, we're going to take 9, upside down 9, 9.6 pi divided by 24 squared pi. Pi's will cancel. That's not part of our answer. So it's just 9.6 divided by 24 squared. And so we can do that here. And that gives us a 0.0166. So about a 1.67%, right? Uh, um, however you want to do that. Okay, so for 37, let's try to squeeze it in too far. So let's give ourselves some room. Here we go. 37, we're going to use L'Hopital's rule to evaluate this. And again, that's a little maybe problem with the copy error or something. This should be as x goes to 0 over here, not here. Okay, so the first thing to use L'Hopital's rule, we have to see is if we evaluate this at 0, do we get 0 over 0? And we do. 6 to the 0 minus 8 to the 0 over 0. So we're kind of evaluating the limit by plugging in x at 0. 6 to the 0 is 1. 8 to the 0 is 1 over 0. 1 minus 1 is 0 over 0. So it does satisfy L'Hopital's rule. We have what we call the indeterminate form. So what we're going to do is we're going to take the derivative of the numerator and the derivative of the denominator, and then we'll take the limit and see if we get something that's usable. Okay, so derivative of 6x minus 8x and x in the denominator here. So the derivative of 6x is going to be natural log of 6 times 6x. Derivative of 8x is going to be natural log of 8 times 8x. It's a derivative of an exponential. Derivative of x is just 1, so that's looking pretty promising. We can at least see we're not going to get 0 over 0 again. So what we do is to evaluate this, we use the property that basically we can evaluate it at 0, and let's see what happens. So without having to rewrite this too many times, when we plug in 0 for x here, this is going to become 1, just like we saw up here, right? When we plug in 0 for x here, this part's going to become 1. And so we've got natural log of 6 minus natural log of 8 over 1. So we could say that the limit as x goes to 0 of this thing, I'm not going to rewrite it, is natural log of 6 minus natural log of 8. Now you could also, because on a multiple choice test, this is a correct answer. However, we could also use properties of logarithms. When we're subtracting two logarithms, we could write this as a natural log of 6 divided by 8, right? Which is the natural log of reducing the fraction 3/4. So you could see either one of these types of answers. Just, yes, this is correct, but this is correct too. And if it's an open answer, I'll accept either one. So you're fine to leave it this way, but, fully reduced, it might look like this. So that concludes the review from exam 2. We'll get into 3 in the next recording.